saying thank you for the invitation. It's a different audience and a different set of speakers than I usually speak with and speak to. I learned a lot about neuroscience yesterday. It was fascinating, and I felt like maybe I had gone into the wrong field. It was just really cool. So my career has been 20 years in survey research, collecting high-quality survey data often for the government or corporations. Thank you, perfect. And my recent research has been into methods to collect like using the lessons from survey research to collect high-quality data for training of AI models. So when we need to collect data from humans to train models, how do we do that? And we know a lot from surveys about how to collect data, so I'm bringing those lessons into training data collection. However, that's not what I'm talking about today. I just want to put that out there if anybody wants to talk about those issues during the break. Today I'm going to be talking about synthetic data for social science research. And from this perspective of 20 years in survey research. And I want to say, too, that there are a few definitions of synthetic data that are floating around. And so what I'm going to talk about is the same kind of synthetic data that John talked about yesterday, which is rather than asking humans questions, right, can we ask the models questions and collect data sort of faster and cheaper than we can now, where we have to first recruit humans to participate. So that's the definition of synthetic data that I'm going to be talking about. Perhaps we could have a discussion about other types if people want to do that. So there has been a few studies really talking about the promise and excitement around this concept of synthetic data. So one of the big articles to make a splash initially was this one by Argyle et al. It really showed the promise of synthetic data. This is in the political science field, and they were looking at the American National Election Survey. And so you can see in this graph here, they're looking at let me see if I can get the laser pointer. Yeah, they're looking at the correlation between gender and age, education, church attendance, patriotism. So this is the correlation of gender with all these. The x-axis here is a Kramer's V measure of correlation. And the dark blue dots are the observed correlation in the American National Election Survey. And the light blue dots are when they just prompted, I think it was ChatGPT-3 to generate data instead. And so the takeaway here from this graph is like these two dots are pretty close together, right? They go through more like rigorous discussions in the paper. But the takeaway here is just like these dots are pretty close together. It looks like the synthetic data is replicating the same relationships we see in the survey data. And so that's the correlation for gender. If you look at more correlations, again, the dots are pretty close together. And they conclude here that GPT-3 reliably answers close-ended survey questions in a way that closely mirrors the answers given by human respondents. This paper made a big splash, and a bunch of people started thinking like, oh, humans are so expensive and annoying. Like, we can just use models now to collect data, right? There was a lot of excitement. And then there was a follow-up paper by Bisbee et al., also using the ANES, the American National Election Survey, and they came to a different conclusion. So here they've got slightly different graphs. The x-axis here is a feeling thermometer. So it's a score from 0 to 100 about how positively you feel about a given group. And if we look, so here we're looking at how Democrats feel about the Democratic Party, liberals, conservatives, and the Republican Party. And the red dots and the red bars are the estimates from the survey data. So that red dot is the mean, and the bar is the standard deviation around that mean. Like how much variability is there in the survey data in these thermometer scores, these 0 to 100 scores. And so what you can see is that the red, so I should back up. So the red is the estimates from the ANES data, and then the black is from ChatGPT 3.5. And again, we've got point estimates and standard deviation lines there, right? Of course, yeah. How Democrats feel about the Democratic Party, or liberals, or conservatives, or the Republican Party, yep. So, and the feeling scale runs from 0 to 100. We saw this in John's talk. It's often like a little slider that you can move back and forth. How do you feel about this thing, right? So you might grab it and say, oh, I feel this way about Democrats or Republicans or whatever. And so the takeaway here is that, we've got the same scores for the independents and the Republicans, but the takeaway is that the synthetic means, those black circles, are near the red triangles. Like we're kind of getting the same point estimates. They're within one standard deviation of what you get from the survey data. but we see much less variability in the synthetic responses. So those black lines are much shorter than the red bars, meaning that the models aren't capturing the diversity of opinions that we observe in the survey data. So he's looking at the same survey, he's using a slightly newer model, but he's kind of coming to different conclusions. Like, wait a minute, this doesn't seem like it's gonna work as much as Argyle et al. Had suggested to us, right? So I wanna dig in on this. Like, why does this synthetic data approach sometimes work and sometimes it doesn't? And in order to do so, I'm gonna take you on a journey through time and talk about 4 stages in the development of surveys in the last 20 years in my career, right? We're going to talk about probability samples with high response rates, and then as response rates declined, how did the field respond? We moved into non-probability surveys, and now we see the rise of synthetic data. So we're going to talk about each of these steps. First, talking about sort of the heyday of probability samples with high response rates. Did you have your hand up again, Shafi? Or? Okay. Okay. And to a certain extent, this heyday never really existed, but it's a nice sort of reference point to start the discussion. So in this world, we have a population with a mean mu, and it's that mean that we want to understand. We don't know what the mean is in the population. Maybe it's like average income, right? We don't know what it is, but we want to understand it. And so we select a sample, which is a small portion of the population using probability theory, right? We select a sample, and we measure the mean on that sample by asking questions. How much income did you make last year, right? And that gives us this estimate, little y bar. And so that little y bar is our estimate of mu, which we still don't know. However, in theory, there are all these other samples we could have selected, right? So we each could select a different sample from this population. We'd each get a different little y bar. And it's that variability that allows us to put a confidence interval on our estimates. So we've got a distribution of all those little y bars. It has this lovely normal bell curve shape. That's the central limit theorem. And so it's that theory, statistical theory, that allows us to say, okay, our estimate is little y bar plus or minus something that gives us the confidence interval on that estimate. This worked really well. There's a strong theoretical foundation for inference about mu from these little y's. And things were great until response rates started to decline. So here's a graph showing declining response rates to flagship US surveys. It runs, I just noticed this over the weekend, it only runs up until 2014. I can assure you that things have not recovered since 2014, and these lines have continued to go down. So this is not selected data. So these are some of the big surveys done by the US government: the National Health Interview Survey, the Current Population Survey, which is where estimates of the unemployment rate come from. All these surveys are experiencing declining response rates. And when you have these declining response rates, that theory we just looked at on the previous slide with the lovely bell curve, that theory breaks down, and we no longer have a great way to say, my estimate of the sample mean is this plus or minus something, and I'm confident, or relatively confident, that that covers the true value. In particular, we worry about non-response bias. So are the people who are bothering to take part in the current population survey, are they different than those who don't take part, and therefore are we getting biased estimates of the unemployment rate or health behavior? So what do we do when we have non-response in our surveys? We have a few different options. One easy way to get your mind around this is we adjust within cells. So we might form cells based on respondents and non-respondents' age. Those are the columns, right? I've broken age into 2 categories here, and then I've got race and ethnicity in the rows. I put each case, the respondents and the non-respondents, into each one of these cells, and then within each cell I can calculate a response rate. So response rates are low for young non-Hispanic blacks and young Hispanics, and they're relatively higher for the older selected people. Within each of these cells I have these response rates, and then I can take the reciprocal of those response rates, just 1 over, right? And that's then a weight. I give that weight to every Hispanic 18 to 44, gets a weight of 2.9, and so on. And those weights then adjust for non-response bias to the extent that it's related to age and race and ethnicity. I'm going to call these the X variables, these X variables that I have about my population. So here it's age and race and ethnicity. We can extend this approach and do something a little more complex. We can fit a logit model where we're predicting the probability to respond. as a function of a bunch of X variables. So these are going to be, again, maybe age as a continuous variable now, race and ethnicity, might be region, might be whether you're employed or not, whether you voted in the last election, whatever variables we have about the respondents and the non-respondents, we can throw them into this model. We predict that probability to respond for each person, and then we can adjust by the reciprocal of that. There's a lot of different versions of this. I'm not going to get into the fights here. They're extreme. And of course, you could use more sophisticated models like machine learning models rather than a logit. But the important thing here is you really need to have data about both the respondents and the non-respondents. You need to put people in these cells, right, whether they respond or not, and that's often a limiting factor. Another approach, if you don't know anything about the non-respondents, which is often the case, is you might set up a table like this where I put these P's now are the proportion of observed people in the sample who are in the 1844 cell, and the observed people in the sample who are in the 18 to 44 non-Hispanic Black cell, right? And then I know in the population, this is the distribution across the rows. I get that from the census website. And this is the distribution in the age ranges. I made these numbers up, so please do not take them as true. And so I've got the P's, the observed proportions in the respondents, and I've got these true values out in the column and row totals, and then I can just solve for the W's that make that true, right? So how much weight should I give the cases in this cell so that in the end I end up with 30% in this row? It's just a math problem, right? So we can solve for those weights that make this true. Here, I don't need any information about the non-respondents, but I need to have good values for the row and column totals or proportions, right? So I still need this external information about the population, or this process isn't going to work. And so techniques like this, more sophisticated ones as well, have worked well for us in this era when response rates were starting to decline. It turned out, I'm just going to summarize quickly here some research. It turns out that the method that you use to do the weights is much less important than those X variables. Like, what characteristics do you put into these weighting models, right? And in fact, we want those X variables to be related to Y, the thing we're measuring with the survey. That might be income. It might be who are you going to vote for, right? It might be, yeah, you get the idea. We want these X variables to be related to that Y variable that we're measuring with the survey. And we also want these X variables to be related to whether you respond or not. Are you taking part in the survey? And so searching for those kind of X variables has become sort of an all-consuming task within survey methodology recently. And the assumptions that these weighting methods are based on is that we have this high-quality data about these X variables. We either have good data about the non-respondents, or we have good population totals or proportions about the people, about the whole population. And that once we condition on those X's, response is essentially random, right? So the expected value of Y, given these X variables and the response indicator, is equal to the expected value of Y given the X variables. You can ignore that R participation decision once you condition on the X variables. If that's true, then all of these methods sort of work fine to reduce bias. The important thing is that you get these right X variables. Okay, however, response rates continued to decline, and we noticed that we were spending more and more time and money chasing down people who really didn't want to participate in surveys. You know, many calls, many visits, many emails. And so the next innovation was to just let people opt into surveys. People who want to take surveys and maybe make a few bucks, right? There are now these big panels that you can join and opt in to participate in surveys. And you, as researchers, can buy samples of just about anybody, right? You can buy families with children under 2 if you want to do a survey of those kind of people. You can buy a sample of teens who vape, right? These are non-probability samples in the sense that we don't know like what the probability of anybody joining that sample was. We don't have any way to, we don't understand that R indicator, that participation decision with these non-probability samples. And so we have observed that there's bias in these in estimates made from these non-probability samples. This is a really nice study from Pew where they compared 9 different non-probability samples, and they just gave them letters here so that you don't know which one is which, and they compared to their phone sample, which is a probability sample with a low response rate. And so here we see on all the variables, it's sample I that has the lowest average absolute bias. So sample I is doing the best here, and then sample H. The probability sample is sort of, I think I've got highlights, yeah. So sample I is doing well, and the probability sample, the American Trends panel, they call it, is in the middle here. And so the takeaway here for me is, again, just like we saw with the Argyle and the Bisbee papers, sometimes these non-probability samples do well, right? Sample I is doing well, and sometimes they do really poorly. And if we break it down in different ways, so if we just look at civic variables, sample I, again, is doing the best. American Trends panel, the probability sample is not doing so well. And if we just look at blacks and Hispanics, both of them are doing pretty well here at the top of the ranking. So sometimes these non-probability samples are doing well, and sometimes they aren't. And it'd be nice to understand a little better why that is. Yes, do I see a hand? Okay, and then this survey, sample I here, it does stand out as particularly good quality. And this is one where the X variables included not only the demographics that most people are using, age and gender and region and race ethnicity, right? They also included some of these attitude and behavior variables. So they've put more variables into that X vector. And that seems to explain why it is that they're doing particularly well here. There are some more sophisticated techniques to do the weighting, and some of these panels that perform, non-probability panels that perform particularly well, use some of these new techniques. So there's one called Mr. P, or MRP, or multi-level regression and post-stratification. And here we model not the participation decision that we were talking about earlier. We're actually modeling, here it's like who you're going to vote for, was the example in this, where I pulled this from. And so you're modeling who you're going to vote for, like the probability to vote for the Democratic candidate, say, as a function of state dummies. These are just random intercepts. The notation here is a little bit much, but these are just random intercepts for the different states, the ages, the ethnicities, the education dummies. We've got a random slope for men as opposed to women, and then some interactions. So you're really trying to understand this voting decision as a function of all these variables using survey data from a non-probability sample. And in fact, the most famous application of this, they were using Xbox respondents. So you're playing on your Xbox, and a survey pops up, and some people take that survey, right? So who's even using an Xbox, right? That's already sort of an odd sample of people, right? So given that you're using your Xbox, how likely are you to take part in the survey in the middle of it? So they collected these data. I'm sorry, I forget. I forget why I got divergent, got into the Xbox situation here. But they're trying to predict who you're going to vote for based on this survey data that they collected on the Xbox. So they asked state and age and ethnicity and education from these Xbox respondents, and they're modeling this who you're going to vote for decision. They predict the proportions in each cell. They called that theta J. So using this model, then you can predict for each unique combination of age and gender and education, you can predict like what's the share of people who are going to vote for the Democratic candidate. That's theta J for each of the J cells. And then they post-stratify that. So they just weight it by the known total in that cell, which again they get from census data.
It can be a high degree polynomial, right? There can be correlations between those alphas, right?
Sure.
Right, that needs to be just linear correlation.
Yeah, there's correlations between these alphas. We've got some interactions here. Yeah, there's more to the model here. So it's a Bayesian model, and they're making assumptions about the distribution of these alphas that I just didn't put on the slide because I didn't want to overwhelm. Yeah. So this model has worked rather well. As I said, it predicted the 2012 election outcome from a very skewed sample of people playing Xbox and taking surveys. This was like the big the big success of this approach. It doesn't always work. It happened to work very nicely in this one case. And I've got a graph actually at the end that I can show if people are interested about that. There's another fancy approach. This is one the economists tend to like, which is called entropy balancing, which is a play on that solving for the weights that make the marginal distributions true. So here we were trying to minimize the distance of the weights from a constant, the entropy distance, that's this formula here, subject to constraints that the x's should equal the population means or totals for those x's. Or we could put in constraints about the variances and the covariances. So this technique also can work well with non-probability data. So I'm just trying to show you that these weighting approaches can get more and more sophisticated when we're dealing with lower and lower quality data. And again, this slide is largely a repeat of a previous one. To reduce the bias, the most important thing, aside from, is not the fanciness of the model or the Bayesian or technique that you're using. It's the correlation of these X characteristics with the thing you're trying to predict, which is, in the previous example, Democratic vote share, and a correlation of these X variables with this R participation decision, whether you're opting in and participating in this non-probability panel, whether it's a survey that pops up on your Xbox or you're signing up to take surveys for a couple of bucks online. And we've got the same assumptions going on here. And so now we come to the fourth stage with this, which is this synthetic data. So now people are saying, you know what, these non-probability samples, they don't always work. They're still expensive. They take a while. Maybe the best thing to do is to just use these models to generate some synthetic data. We can prompt the LLMs to give us some survey responses, and we can do a lot more surveys than we can now. So how do we ask these models for responses? We saw a little bit of this in John's talk yesterday, but I want to dig in on it. The traditional approach, and this is what John talked about, is called persona-based prompting, and this is what Argyle and Bisbee did. So the prompt you give into the model is something like this. I describe myself as a conservative. Politically, I'm a strong Republican. I'm white, I'm female, I'm lower class, I'm young. When I'm asked to write down 4 words that typically describe people who support the Democratic Party, I respond with, and then the model should give 4 words here, right? And this is how you might elicit survey responses from a survey. So this is the prompt that Argyle used. Bisbee changed it a little bit and experimented with putting it in the second person. So you are a conservative, you are a strong Republican, you are white, and he's found that worked a little bit better. So there are options here. But what I'm interested more in is like these X variables, right? Like what are the characteristics that you're giving the model? Here it's political affiliation and sex and gender, gender and race. Those are those X variables we've been talking about, right? Why did they pick those ones and what are they putting into this model? So this is what I'm calling persona-based prompting, and you might think of this as a continuum from like a lot of detail about the persona to no detail at all about the persona, and we can be at different points on this scale, right? One of the approaches that I'm really interested in is I'm calling in-depth context. So this is a study, here it is. This is a study from Park et al. I believe Park is at Stanford. They selected 1,000 participants. They did 2-hour interviews with each person individually, right? So I did a 2-hour interview with Rich, and then I did a 2-hour interview with Shafi, collecting a bunch of information about their personal histories, like how did you grow up and where did you go to college and these kinds of things, right? And then they fine-tuned 1,000 models. So one model for each person. So now I have a Rich model and I have a Shafi model, right? And then they asked questions of those models to generate the synthetic data. And they compared the survey responses from the actual participants to the survey responses that they got from the models. And they found that the correlation there was about 85%, which isn't 100%, but also if you ask people the same questions twice, you don't get 100% agreement, right? So so they found that this was pretty good. They took this to be pretty good evidence that their approach worked. Now you're doing something slightly different here, and I want to make sure that I get this point across, right? In the previous slide, the Argyle, right? Like I'm a Republican, I'm young, I'm white. What am I gonna, what are some words that I use to describe Democrats? You're looking for sort of a person like this, right? Here, you're really looking for the responses of a given person. What is Rich going to say to this, right? What is Shafi going to say to this? So it's a slightly different approach. You're not looking for somebody kind of like Rich, but somebody like who actually has the same like upbringing and educational and business, like employment history as Rich. That's only you, right? Nobody else is quite like that. There's also this idea called zero context prompting. So, yep.
I just had a question about the previous one. How does the residuals look like? Are they always biased toward the center? So was any pattern of the residuals between the individuals?
You're asking about the residuals?
The 15%.
Yeah, I'm sorry, I don't know. We can look at the paper together in the break. So at the other end of my continuum, though, there is this idea of zero context prompting, where you just ask the model, how much, if at all, do you think the ease with which people can legally obtain guns contributes to gun violence in the US today? A great deal, a fair amount, not too much, and not at all. And I tried to sort of mock this up so it looked like I'm actually asking ChatGPT. I don't know how you guys feel, and you can tell me. This makes me a little nervous. This seems to me to be not a great idea. I don't know, I have like a sort of a intellectual discomfort with this approach. I'm not sure what the model is going to do here. Is it going to give like a consensus approach? Is it going to draw randomly from a distribution of approaches that it has in its mind? And I think what's making me uncomfortable here is something that I think John was hinting at yesterday as well. We don't really know like what the model is doing when you ask it these questions, right? And I point this out because I think if we're uncomfortable with this, like, doesn't that discomfort also apply to the other approaches, right? I mean, why does giving age and gender somehow make it seem a little bit more reasonable to ask a model these questions, right? So I think it's important to sort of introspect on why does this not seem like a great idea. I did try it with the Claude model, which is the one I subscribe to. So I asked Claude this question, and it just gave me like an essay about gun violence and how. So then I added in this part. Respond to the following question. You must provide answer choice A, B, C, or D. Do not provide any other response. And then it gave me a D the first time I tried it. And the second time it gave me a B. And the third time it wrote me an essay. It didn't follow my instructions at all, right? So I thought I would come in with some data about, maybe get a distribution, but it wasn't working. It wasn't going to follow my instructions well enough. Tiny aside before I move on, one of the problems we have with the non-probability samples is these people who are taking surveys for cash, right? This is a lot of what they're doing, right? Rather than answering the questions for themselves, they might be putting them into a model and just typing in what the model says. Not maybe so much for a closed-ended question like this, but if there's a free text question, hey, write a few words about what you think about, climate change. A lot of people are putting that into the model and just taking the responses there. So in the non-probability samples, we're probably getting a lot of this zero context prompting responses. That's a slight aside.
And maybe with the non-probability, you mean people like prolific or on those?
Yeah. Mechanical Turk, there's a lot of these. Uh-huh.
So you were saying here the fact that the first time it produced a B and the second time a D is not good, but before you were saying the nice thing about people is that if you survey a bunch of people, you get different responses. So here you're getting a model that has different responses.
Yeah. And I wanted to sort of graph it and see, like, is there a central tendency or something like that, right? But it wouldn't play along. Like, it wouldn't give me more than 3 responses. I think my discomfort here is that I don't know what it's doing, right? Is it drawing from a distribution of the responses that reflect the US population, the worldwide population? I'm not sure what it's doing. That's really the source of my discomfort here.
Yeah. Also in the model, you can change like the temperature parameter, right?
Mm-hmm.
Be more random or less random.
Mm-hmm.
So that seems like another thing, is something that could encourage
Right.
variability.
Right. I mean, and John wrote that nice package that I didn't know about until yesterday. So that would be a nice way to quickly get like thousands of responses here. Yes?
So the reason that Claude is writing an essay is that it's following instruction in the system prompt, which asks it to discuss broader views when it comes to controversial topics. So Claude does instruction follow, but just not following your
Not my instructions. Okay. Is there a way to turn that off?
So what you are saying is that Claude is a teenager.
Yes?
After they say that like answer and then A, B, or C, so it will maybe give you more responses than B. Like I have tried it with like if you specify after this prompt answer and type your answer here in brackets,
Oh, okay, okay. Yeah. Yeah, I could definitely have tried harder to get this to respond. Yes?
Perspective. So, is this question being asked to Claude at each iteration represents a different individual in search for your Y
Mm-hmm.
sample mean or average? Or is this sampling the population and giving you the Y hat estimator or average?
Yeah.
So I think there's two different understandings of ask it 1,000 times.
Right.
You want, for robustness, you'd want to get constant mean, and variance rather than non-stationarity, which is infinite mean, infinite variance.
No, I totally agree. I mean, and that's my discomfort, is I don't know what it's doing, right? Is it picking an average person and then always going to give me that person's response? I mean, clearly not, since it gave me different responses, right? Or is it drawing from a distribution that reflects a population, and what population is that? Yeah, I really, we don't know, right? And that's what makes me uncomfortable about this. Yes?
So this is the state of today. It looks like now, when you pay people to do this, they will use ChatGPT or whatever to answer this question. Are we gonna see this bias becoming like in the next 5 years, like all the answers are LLM answer anyway?
And we have seen some of that already. So Pew has done some work about noticing that, especially with free text questions, they tend to get very similar responses across respondents, suggesting, this was years ago, but suggesting that they had all gone to Google and asked something about like the bicameral legislature, I think it was, right? They got very many similar responses. So a lot of the work now is in trying to detect people who are using the tools to fill in the free text and distinguish real from fake so that we can throw out the people who are doing the fake. Did you have something?
Excuse me, can you wait for the mic? Oh, thank you.
There are kind of open source models you can see exactly how they were trained, and then you can maybe tweak them and do something, and then you know what things came in there.
Right. Yeah, and that's what John
concluded
concluded yesterday as well, is if we had open source models that we understood better, right? Like we can get in there and understand the data generating process. That would be helpful, for sure. All right, I'm gonna move on. So I think there's an important question here about what X's, like what information do we give the model when we're asking for these synthetic responses? And I don't see this discussed too much in the literature at all, so I think this is an important point that survey methodologists can contribute here. What variables should we be giving the model? Where on this continuum do we want to be? Bisbee et al. Did do some exploration of this. So he looked at, So he looked at the outcomes that you get for when you give prompts with different amounts of X variables. That's what it is. So he's looking at prompting with just the demographics, prompting with political variables only, and then prompting with combined demographics and political variables. And he's breaking the results here down by Democrat, Independent, and Republican. And here we're looking again, these are these feeling thermometers, looking at, so Democrats feeling towards Republicans, towards liberals, towards the Democratic Party, towards conservatives, okay? And so we're gonna see 3 sets of dots reflecting the 3 different prompts. And the x-axis here is this mean absolute error. So he's comparing the synthetic responses, the 3 sets of synthetic responses, to the survey data. And you can see that the mean absolute error is lower when you're prompting with both politics and demographics. So giving additional information to the model helps it do a better job of reflecting the true survey responses. No, this is the American National Election Survey. So this is a good probability survey. Yep. So we're comparing synthetic responses generated 3 different ways from 3 different sets of prompts to the probability data, the ANES. And low here is low error, low bias is better data quality. So I think the first question is, what X's do we give the model? And more is better. We kind of see that in surveys as well. We call it the kitchen sink approach. Just give them everything you can. Like use all the variables you have in your models. Another approach, the second important question is, given those X's, can the model predict Y? And this is where the synthetic literature is kind of hung up, in my opinion. They're overemphasizing on this question and underemphasizing the previous question. But there's a lot to say here. I think, as we've just discussed, like, we don't understand the data generating process. How is the model getting Y from those X's? What is this function? We don't know. Maybe with open source models, we would know a little bit better. We'd know more. We know that things can go wrong. There's hallucination problems. We can play around with the temperature, as somebody suggested. There's temporal issues, right? So these models were trained as of like August 2024 and haven't been updated since. There's social bias. So there's a lot of papers written that there's a consistent bias in the training data towards the majority group, and therefore a consistent bias in the responses that you get towards the majority group. Other people feel no, they feel sort of the opposite. There's a machine bias. There's just inconsistent bias across topics. The models are behaving in sort of inconsistent in ways we don't understand and producing a lot of noise. So they have bias, but it's like very concentrated within certain groups or certain topics, and it's inconsistent across questions, leading to just a bunch of noise in the data. And they're also, the answers that you get are sensitive to the prompt wording, the prompt style, the order in which you put the X variables in. Like, do you do political ideology and then gender and then race, or do you do race first? It's very sensitive to these kinds of things. In my opinion, these approaches are really solving the wrong problem. So we started with probability samples with high response rates, right? And then, response rates started to fall. And we're getting further from what I'm sort of wishy-washily calling the data we want. What we want is like high-quality data from a probability sample, right? We're getting further and further from that because response rates are falling, and now we're starting to use non-probability samples. Here's more data from a ton of other people that you didn't select and didn't ask about, right? And then in the last stage, we're using synthetic data, and we're getting like even more data from an unknown process. So we're getting more and more data, but it's getting further and further from the data we want, which is responses from a probability sample of people. I think the problems we do need to solve, instead of that wrong problem, I think the right problems to solve are to improve these bias reduction methods. That's why I spent some time going through those weighting approaches. We need high quality data on more of these X variables, and we need good social science theory to know, like, what are the X variables that we should give the models or use in our weighting reduction methods. And there are a bunch of ethical issues. I'm not sure where I am on time here. We did talk about some of these ethical issues yesterday during the panel, so I thought I would, so do I have some time? I have 6 minutes, okay. So I will touch on these because I do think they're important. In terms of autonomy, agency, and consent, of course, real people can refuse to participate in our studies. So this happens all the time, right? This is why response rates are declining. A model, Claude's behavior aside, often doesn't refuse to participate, right? It doesn't have the agency or the autonomy to say, like, I don't want to take this survey right now, or this question is poorly worded and I'm not going to answer it, which humans do all the time. The people on whose data the models were trained don't have an ability to consent to the use of their data in these synthetic responses, right? I know that I looked up in that database that was made a big splash like 3 weeks ago. So some of my papers have been used to train these models, right? I didn't consent to that. And so then now that data is all being used to create synthetic responses potentially. I don't personally have a problem with that, but some people might, and there's no way to really gather that consent or keep track of it, right? I worry too that the models can generate sort of a false sense of inclusion or representativity. Like, oh, we didn't have enough women in our sample, but we just went out to Claude and got a bunch of them, you know? Or we didn't have enough like 18 to 24-year-old African-American men. Like, that's a group that's really hard to get responses from, right? But hey, we can just go to the model and get as many as you want, right? So the data may look in a superficial sense like, oh, it's really balanced and we've got great inclusion, but actually you don't, right? That's something I worry about. And then the lack of reproducibility is also a problem, right? So there's temperature settings, there's randomness in the model that we don't necessarily understand. The models themselves are changing. So if I go back to Claude next weekend and try it again, it might be a slightly different model with a different system prompt and give me different responses, right? So there's all sorts of ethical issues here. I do want to end on a good note, which is, I think one of the really stellar use cases for synthetic data is about pilot testing. So I review a lot of surveys. A lot of people send me surveys like, hey, will you just look at this and tell me if my questions are any good? Spend a lot of my time doing that. And one of the things I'm constantly pushing back on is you have too many questions, right? Like you have to get this down to like 3 or 4 questions or people aren't going to do it. And over time, like maybe they'll do your 10-question survey, but the next time they get a 10-question survey, they won't do it, right? So there's like a cost, a social cost of repeatedly surveying people. And I feel like some of the questions I see are poorly worded, and I don't have a sense of like, what are they going to do with this data? How are they going to analyze it? Is it actually important? A lot of the questions just seem like nice to have, right? Like, oh, I thought it'd be cool to ask that question, right? So I think we could use synthetic responses to, hey, let's make a data set of 2,000 responses to your crappy survey, and then write some code, right? Do the analysis and see which questions are actually important in your, like which are you going to put in the final table or final paper, right? And then let's only ask those questions. Yeah, yeah. That's like hypothesis generation, Shafi said, exactly. So that I think is actually a really good use of synthetic data. I was excited to see that John yesterday had a tool to make it really easy to generate synthetic data. I would love like a plug-in to Qualtrics, right? So I make my Qualtrics survey and it spits out 1,000 fake responses. Then I can just play around with those and see if those data are gonna give me what I want. So that's me ending on a happy note. I'm happy to hear what everybody else thinks on the happy side or the not so happy side. Thank you very much.
Surveys with high frequency response rates, lower frequency response rates over time. And let's say the access to the internet opened up in 1991, it got more prominently used in the year 2000. The data that the models are training on, Claude, are all the data that's been contributed to the internet from ancient history until now. But the declining response rates and the declining participation, if you will, in this exponentially expanding data set called the internet, on which the model's training may simply be weighted more and more over time to the low response rate.
Right, yeah. So he's saying that the data the models are being trained on may be sort of declining in quality as the amount of like garbage on the internet grows, or they're not.
Lack of quality response.
Yeah. Yeah, I think that's a problem. And we saw a paper about that yesterday. I think his name was Nicholas, is he here? Talking about like model autophagy or model collapse, right? Models that are trained on models that are trained on models, right? The same kind of thing could happen here with data. If we've got non-probability data and then we train on that and then we generate responses from that and then we train on those generated responses. Yeah, I worry about that exact kind of thing, yeah.
Hi, thank you, great talk. I wanted to go back to the discussion of kind of these, the privacy trade-offs of like the amount of data that you collect about people. So like, if you collect more information, it might be easier to find the X variables that correlate with your Y variable. But of course, suppose the X variable is like being undocumented, you don't necessarily want to collect that. This seems to me like a problem that's quite unsolved in machine learning. I'm curious if there's insights from like survey land that might be useful here about how to balance like collecting data that is a good predictor, but not wanting to infringe on particular privacy rights.
I mean, survey researchers, we often collect these kind of very sensitive variables, right? So I worked for many years on a survey about drug use where we asked people nosy questions about their use of illegal drugs. I would like to be in a world where we can collect that kind of data and then promise to people that we're going to be careful with it, you know? That's the kind of survey data that I've collected. I understand your concern, though, that some of these variables are very sensitive and could fall into the wrong hands. The best X variables are ones where we have this kind of external benchmark data, right? So some variables are just never going to be appropriate there because we don't have the right kind of benchmarks to use them. I don't feel like that's a super satisfactory answer to your question, but that's what I got. Yes?
So 2 comments. One is that I think that if someone wants to do silicon sampling without spending the effort to collect actual data, that's never going to work. What it's promising is after you've collected a bunch of data, you do data augmentation, given access to some of ground truth. I think augmentation is more promising than getting rid of the need for survey completely.
Yeah, I mean, I think that just means that you're sort of, you're over here, right? So you're taking the survey data that you already have and using it as a prompt to get more variables, right?
Right. And then the other one is that it's a great point on pilot study. we are currently doing a statistical methodology paper on examining the silicon pilot study to increase discrimination but reduce bias. So increase the discriminatory power, in other words, the variance in responses of the phrasing, but reduce the bias induced by the phrasing.
Okay.
So we can, for example, understand whether it's better to ask pro-choice versus anti-choice or pro-life versus pro-choice.
Right. Yeah, that's a great idea. So some of the questions can often be very sensitive to the wording. You get different responses from the models and from the people, right? So can you use the models to understand which the best phrasing and then use that for the people? I think that's a great idea, and I'd love to see if it works out, right? Does it actually, do the human samples replicate what the models did? Yeah.
Hi. So these days, I think it's very difficult, right, to get a response to surveys. You know, people don't pick up phone numbers that they don't recognize. They don't, you can get hacked and so on. So have you seen situations where survey companies make up the data fraudulently? They just make up the thing and pretend that they come from real people, but they...
Absolutely, yeah. There was just a few weeks ago, there broke a big story that there was an important market research company that had been making up data for 10 years. People had been buying results from them, and it turned out that they were just making that all up. Yeah, so they're paying people to make up data. Yeah, but so there's definitely rumors about that kind of thing, concerns about it, and again, some sort of statistical techniques trying to detect it. I haven't seen rumors about people doing synthetic data instead of actual survey responses, but I'm sure that that's coming as it gets so easy to do these kind of synthetic samples.
Thank you.
Yeah.